My name is Isima Emmanuel. I'm a Senior Solutions Architect here at AWS, and thanks for joining this session. I'll be talking about generative data and security best practices regarding generative data. Just yesterday, I was running through the news, and I saw something that I don't know if you've heard about it. OpenAI and Apple recently just announced a partnership that they'll be working together on basically doing generative AI, right? So when you start working on your Apple devices, like your Mac devices and all that, your data is being taken and in a way that is being used at the back end, and you'll be able to get some good things. Basically, it's a way of democratizing generative AI. But what it's made me start thinking is data security, right? You know, you're using your Apple devices in some way, some of your data is being taken away. How is that data being managed securely, right? And that is part of what we're going to be discussing today around, data security in the context of generative AI. Before moving ahead, I want to just do a quick room check. How many of us here are familiar with generative AI? If you are, can you please raise your hands? Oh, awesome. How many of us are aware of things like RAG? Have you worked with vector databases like something like Amazon OpenSearch? Awesome. Are we comfortable with data security when managing generative AI applications? Have you done some stuff in that space in the past? Well, this session, part of it, I'm going to walk through what we see when I speak to customers out there around generative AI and data security. To help me go through this, I have a couple of items. One of the items is when working with generative AI applications, is there a need for you to store data? That is a question I constantly get from customers. Another question I get from customers is, if they need to store data, what kind of controls do they need to put in place? Now, outside the controls, how will they be able to trace and be able to audit their data when they are working with generative AI applications? These are some of the items I intend to consider as we're going through this presentation. But before proceeding ahead, let's look at an architecture I typically see that most customers have. Now, if you look at that architecture we have on the screen, you would see a user interacting with a generative AI application, and you would see at the back end, there's Amazon SageMaker, which is our MLOps service, if you're very familiar with AWS, and it's using RAG. RAG refers to retrieval augmented generation. It's just a way to improve the response you get from generative AI applications by providing contextual data. So in this case, Amazon SageMaker is using a RAG notebook, which when this user here asks a question, that is going to go into the search engine, which is a vector database running on Amazon OpenSearch, and that is going to go into a knowledge base agent and eventually into a knowledge base on S3, right? Now, if this user is trying to get something, let's say you ask a question, what will happen is that question in form of embeddings is going to go into the knowledge base. The knowledge base is where we have the contextual data, and that contextual data is going to be sent all the way to Amazon Bedrock, which has already existing foundation models. Now, those foundation models are already pre-trained. They are going to use this contextual data in providing the right response to the user that is asking this question. Typically, this is what we see in generative AI applications. It may not apply to all use cases, but this is what we generally see. Now, the question here is, during this entire workflow, how do we take care of data security? How do we ensure that data is secured? Now, returning back to our initial agenda, we asked the initial question, how do I know if I need to store data? Is there really a need for me to store data? With some customers that I've spoken to, sometimes there may not be a need for you to really store data. For instance, if you're just working on a project and you're just creating a generative AI application for just a simple project, and when you're done, the data is not really needed. In that case, best practices, we want you to delete that data. You don't want to keep the data, because as much as possible, you want to keep people away from data. So the first thing there in that case, maybe you need to delete that data. If the data is not needed, get away of it. Get it away. However, if the data is needed, that is when we'll now start speaking about controls. And then the question I next get from customer is, what kind of controls do I need to build in place? Do I need to bring in identity-based controls, or do I need to bring in data protection controls? Some customers already have identity-based controls already in place, and they feel, is this good enough, or do I need to build additional controls from the data side? Now, I'm going to talk about this from AWS side. From our side, we basically advise customers to bring in defense in depth here, which means it is very, very fine for you to build both data and data protection, both identity and data protection controls. However, regardless of the controls you have in place, there are a set of best practices that you want to look into. And these are the best practices. If you must store data, it is very, very important that you keep PII data out of your RAG provider. If you remember my initial architecture, the RAG provider is S3. You want to ensure that you keep PII data out of that RAG provider, which is S3. Another thing that we recommend is that customers always keep a human in the loop for quality control. You want to ensure you have a human in that loop when you're working through, manipulating your data. In that entire flow, you want to ensure a human is there for quality control. Now, one thing we've established here is, yes, there is a need to store data. How do we now manage that data? Let's start from looking at identity-based controls. To enable us to look at identity-based controls, if we return back to our initial architecture, we are looking at a user here, and let's imagine that this is your environment. You have different personas in your environment. You have a guy who works on your billing team. He helps manage, your GenAI applications on the billing side, and you have another guy who works on the finance side and helps to manage your GenAI applications on the finance side. Now, you want the billing guy to be able to upload data to your knowledge base, which is S3, but you only want him to be able to read and write the data in S3. You don't want him to read data, for instance, from the finance team that is on the S3 bucket. So what I'm saying is, you have an S3 bucket. Within your S3 bucket, there are certain data that he is uploading into S3 that is relating to billing. There is also data there that is relating to finance. However, you only want to give him access to just billing and not finance. What you could probably do there is to create folders within S3, and then you can use constructs like AWS IAM roles to give him fine-grained access to only those folders that are related to billing. While the folders related to finance, he does not have access to that data. So basically, you are using IAM roles and giving him fine-grained access to just the data that he needs. Now, when you are growing as an organization, it is possible that you don't want to keep creating roles all the time. We have a construct called attributes. And basically, when I'm talking about attributes, I'm talking about tags. You can use tags to say this specific principal would have access to this particular folder, and that is all he has access to. Every other thing is denied from. So basically, you can use tags to say this particular user using this specific role only has access to this tag with this folder with this tag. So in that way, you're giving him fine-grained access only to that specific folder. Is that clear to everyone? Yep. Cool. Another thing you could do is using groups. Groups is just a user community. It's just a group of users that you're giving access to a specific folder again. Again, remember, the most important thing here is that you're providing fine-grained access to a specific folder, and it doesn't have access to other folders. Now, this is from the identity-based side. Now, if you want to take this further, you want to look at also from the data protection side. We spoke about data protection. How do you do that? Now, if we return back to our architecture, when we're going to data protection, now we're looking at S3. We have those data sitting on S3. How do we ensure the data at S3 is good, where data at S3 is secure? How do we provide that? We have a couple of AWS services that could help you here. Some of you may already be familiar with some of these services, but I'm just going to mention some of them again. One of them is AWS KMS. AWS KMS is a way for you to encrypt those, use AWS KMS keys to encrypt those data at rest when it's in place. But again, returning back to our architecture, you remember data is moving from your knowledge base, right, to your open search, which is your vector database, and it's moving all the way to Bedrock, right? So data is moving between different AWS services. Now the question is, when that data is moving from one service to another service, how do I maintain security, right? Which is data in transit. That is what I'm basically saying. We have a service called AWS Amazon Certificate Manager, which can also help you to manage, data as it's moving from one end to another end. We also have, AWS Private CA if the connection here is private. Now, if you remember, one of the best practices I mentioned is that you want to keep PII data away from your knowledge providers or your knowledge base, which in this case is S3. We have a couple of services that could help you here. Most of you are already familiar with this. Amazon Marseille is a service that can help to detect PII data. And if you want to make this, really become pragmatic, you could, have a flow where when that user is uploading data to Amazon S3, you have something like maybe Amazon Event Bridge checking for that. And whenever the user makes that upload, it triggers a Lambda function, which either redacts the data or, anonymizes the data, makes the data such that nobody is able to see that PII data, right? That is a way to go about it. But we have a service that could totally take this all away from you, Amazon Comprehend. With Amazon Comprehend, you could totally redact any PII data you have on your knowledge base. Now, I have a QR code here. You can use your camera on that. This QR code would take you to a blog written by some of our architects that talks about how to use Amazon Comprehend to redact PII data. Good. Now, we've talked about two things. We've looked at it from the identity side. We've looked at it from the data protection side. Like I mentioned, in AWS, our recommendation here is not to go with one or the other. We recommend defense in depth. So as much as possible, after building identity-based controls, it is very, very recommended that you also build in data protection controls to ensure that you have that defense in depth there, right? Now, how about for heavily regulated customers? Some of you may be in very heavily regulated industries where compliance is a big deal. You need to be able to demonstrate auditability. You need to be able to display traceability. When a user, for instance, is moving data across different services. Now, let's focus now on the user. This user is, moving data via the various services, is interacting with Amazon S3. Let's imagine that this same user has processed this data on Amazon EMR. He's done some data processing there, right? Amazon EMR, for those who doesn't know, is our Elastic Map Reduce service. You can use it in processing data. It's built on the Hadoop framework. So let's say you've done some processing there. You've created a catalog using a service like AWS Glue Catalog. For those who are not familiar with Glue Catalog, it's just a way for you to create a catalog of your data. So you've done a bit of processing using AMRO. You've done some things using Glue Catalog. How can you demonstrate traceability of your data? Right? As you're moving through these different AWS services, you're going into S3. How do we demonstrate traceability? How do we demonstrate auditability? CloudTrade does that. But there's something in CloudTrade. Before this particular feature I'm going to mention now was released, typically if you go to Amazon CloudTrade, what you would see is that a role is performing this specific action. This role is accessing this S3 bucket. This role is moving from EMRO here to that. Right? But there's a limitation with that. Typically, if you're troubleshooting this or you're trying to find out which user made that API call, you're seeing a role It's vague because so many users can assume the same role. Several users can assume the same role. However, with a new feature we call trusted identity propagation, what trusted identity propagation does is that it is going to provide access to AWS resources based off the user's identity context. Who is that user? What's the user's ID? What's the username? That is what we are going to provide access to AWS resources on. But on top of that, we are going to share that user's identity context with other AWS services. So again, the user is moving from an EMR studio to maybe a Glue studio, and then doing so many changes along the way, and eventually to S3. We are sharing the user's context across the different AWS services. So at the ending of the day, if you're looking at CloudTrail, you can see user A is the one making the same action on Glue, on EMRO, on S3. You are able to trace who that user is. If you need to demonstrate auditability to anybody, you are able to show all that on CloudTrail and say, hey, this user is the one that made this action. And the reason why he was able to make this action is because we gave him access. User B cannot do the same thing because we did not give him access to do that. So you are able to display traceability. At the same time, you're able to audit and show people what the controls you have in place is providing and limiting. Is that clear to everyone? Cool. So with trusted identity propagation, there are a couple of AWS services that is integrated with. We have Amazon EMR, Amazon QuickSight, Amazon Redshift, Tableau, and any custom developed applications. Now I have a QR code. If you want to, you can also take a snapshot of this QR code. It basically it takes you to a blog written by one of our VPs, distinguished engineer, Becky Weiss. And she writes about using the AWS IAM Identity Center, integration with Amazon S3, using the trusted identity propagation feature, how that enables you show user access to S3, using S3 access grants, and how you can provide auditability, traceability using that feature. That blog talks a lot about this. I want you to take a look at it, and yeah. So to wrap, what we've discussed so far is basically keeping people away from data. We talked about some fundamental principles. Number one thing is, as much as possible, if you need data, provide controls. If you don't need data, you want to take away that data. It could be using something like S3 lifecycle policies. That is the first thing. Data not needed, keep it away from people by deleting them. Those that are needed, you want to start designing controls. Now, when we get to in the context of controls, the question is what kind of controls? As we said, you want to use the defense in depth principle. You want to bring in identity-based controls. You also want to bring in data protection controls. So you want to mesh that together. Use AWS services like KMS, ACM. We spoke around Marseille. We spoke around Comprehend. On the identity side, you want to use AWS IAM Identity Center in providing those fine-grained access for your users. And then we spoke about auditing and tracing at the end. You want to use CloudTrail with the new feature of trusted identity propagation to be able to audit and trace users' actions when they are interacting with your data. I'm going to stop here today. This is all I have for you.